Okay, so for our Desmos activity, what you're looking at is kind of trying to describe how adding different values into an equation actually changes what the graph looks like. So you're going to be using Desmos either on your phone using the app or on the internet if you're on a computer, or I guess you could also do it on your phone if you don't want to download the app. This activity is broken down into 5 parts. Each part is looking at how varying a different value kind of changes our graph. So I'll walk you through part 1 to get you started, and then you can do parts 2 through 5 on your own. So the first thing we need to do is make sure we have Desmos open, and we're going to be graphing these 4 equations on the same grid at the same time. Open it up. And so I want y equals x squared is my first equation, and you'll notice that it is actually red. And so on the left-hand side, I actually get a key. And then I want y equals 2x squared, y equals 3x squared, and y equals 4x squared. I'm going to take my grid graph and I'm going to zoom in a little bit here. So they're a little bit more obvious to differentiate. So I look at these 4 equations and I say, okay, well, what is changing in these 4 equations? And the answer is my coefficient, that number out in front of x squared. And remember, y equals x squared is my parent function. That's going to be my point of reference. So the red parabola. Okay, but as I increase my coefficient, I go from 2 to 3 to 4, I look at where my parabolas are relative to my parent function. They're all inside of the original parabola. They get skinnier and skinnier and skinnier, narrower and narrower and narrower. But they always keep the same vertex point. So those are kind of my 2 characteristics that I notice. Another way of describing it, if you don't want to think of it as skinnier and skinnier, is taller and taller. So originally, my first kind of key point comes at 1 and 1. Okay, right here. But I actually get, when I am at x equals -1 on my second graph, it actually takes me all the way up to 2, so it's taller. My third graph, it takes me to 3, and my fourth graph, it takes me to 4. So we can kind of track the height of the graph. So instead of thinking about it as getting narrower and narrower, you can think of it as getting stretched vertically. So I always use the analogy of, if you think about like Play-Doh or silly putty, or like even your gum, if you take it out of your mouth and play with it, and you take it and you start pulling on the ends and stretching it out, we notice that the middle gets narrower. That's essentially what we're doing when we have these larger coefficients, is we're taking the ends and we're stretching them out. But in our case, our vertex down here at the bottom is still fixed. It's just the top that's getting pulled upward. So when I go back to my sheet and the question, how do their appearances vary in terms of width and direction? So graphs get narrower, skinnier, and they're all still opening upward. Okay, but their vertex is always in the same place. Okay, so go ahead and try it out using Desmos for part 2, answer the question. Part 3, same idea, 4 and 5. And then any conclusions that you might want to write down in some general statements of how can you know what a number is going to do to your graph.